I subscribe to those Fluke Plus newsletters, and every once in a while they'll send a survey that sometimes has a contest attached to it, sometimes it doesn't. And Fluke's a company that I like a lot. I have quite a few of their tools, and as a matter of fact, their multimeter, the 117, is probably something I use every day, every other day. It's the digital multimeter that I carry with me on a regular basis. So I took one of those surveys the other day, and I got an email a few weeks later saying that you won the prize that was attached to it. And the prize happened to be this Fluke C550 tool bag. And it didn't have the meters in there. I was just, I put the meters in there for the icon of the video. I was taking a picture of it. But I was completely surprised. I don't take surveys all that much, and this is, you know, just a company that I happen to like, and goes to show that Fluke cares about their customers because they reward you or give you a chance to be rewarded for taking your time to take the surveys. So I got the bag for free, and I want to thank Maureen at Fluke. She's a very nice lady, and she was very courteous and said it was going to be okay if I mentioned that I took the survey and won the bag on the forum. So I figured the least I could do is do a review on the tool bag and tell you about the quality and construction, in my opinion, what it was like. And I thought I'd try something neat and see how many Fluke instruments we can actually get inside this tool bag. So I got a couple of my rigs out of my work truck and brought them in, and I think that's the only way I'm going to be able to max out this bag, because as you'll see in a second, it's pretty deep and pretty wide, and you can fit quite a few multimeters in it. I'm going to be testing out a new camera rig that I've got to do overhead shots, and we'll see how that goes. Let me know what you think of that. Before we get into the review, picked up another moderator, actually from Australia, who's going to be moderating a couple boards on the forum, and I'll leave a link into the video that I talked about looking for moderators and pre-registered users below. This week I've been uploading some files that I use on a regular basis to the download part of the forum. It's access control forum/download. It may be downloads, plural, but there'll be a link below. And I uploaded a couple of reference sheets that I use for some of the telephone entries that I work on, and I uploaded a customer contact information sheet that just has some questions on it that when you do get a new customer that sometimes you forget to ask, like the entry code to the telephone entry to access the property, or what the password to the alarm panel is, or what the password to the fire panel is, or what the key box password is, those type of things. I uploaded about 5 or 6 files this week. You don't have to be a registered user to download these particular files. They're in the guest folder, and anything that's in the guest folder, you don't have to sign in or be a registered user to download. So let's relocate the camera and get an overhead shot and do a review on this bag and see how many Fluke instruments we can actually get in the tool bag. Let's see. I've got my regular case that I carry that's got all my Fluke instruments, or I shouldn't say all of them. It's got some of them, but this particular case has the multimeters and LCRs and insulation testers that I don't use on a regular basis, but I have to keep them well protected, and I have to keep them locked up so no one can just walk away with them or use them. So let's take a look at that real quick, and I'll go through some of the meters that I carry and why I carry them. All right, let's take a look and see what we got. Fluke's 337 clamp meter. It's the only clamp meter that I carry, but sometimes I do need to measure current and to use the digital multimeters as an ammeter that I have to break the circuit to do that, and sometimes it's not time efficient to do that, or safe to do it either. So this is a high current AC/DC clamp meter. Sometimes I use it as a digital multimeter, but I rarely I rarely use the DMM functions that are on here. I don't do much electronic stuff out in the field. Most of the stuff I do is here on the bench if I've got to check something out. But sometimes I do need a little bit more resolution and a little bit more accuracy, so I have the Fluke 87.5. It has a couple features that I sometimes use other than that, such as a low pass filter. Every once in a while I'll be working in a facility. The one that comes to my mind is a post office. They have those big long conveyor belts, and a lot of those guys have that with variable frequency drivers and variable frequency motors, and some of the harmonics can kind of throw off your meter. Especially the 117, but this has a low pass filter on it, so it will not wipe out, but it'll just let the lower frequencies go through, so those higher harmonics don't influence the reading that you're getting. Also has the ability to measure peak and a couple other things that I do use. Fluke's 1587. The only feature that I really use on this is the insulation testing, which that's what it's for. It's an insulation meter. This is primarily used for in-ground inductance loops. So I do carry the Supco M500. It is probably what I use 75% of the time, but every once in a while I have, that's cracked. I didn't know that was cracked. Every once in a while I will be testing out a circuit board such as this Elite Omni board, and it has this particular connector. I don't know if you can see that. Probably not going to focus in on it, but I'll show it to you on the bench. This type of connector, and the Fluke 1587 has a handheld probe that you don't have to disconnect the loop wire, and you can just probe it directly from here. Of course, when you do that, you'll want to take it out of the board because you're going to be sending 500 to 1,000 volts through it, and you don't want that to go through the board. That's typically the only voltage that I'll send through there, or I shouldn't say that. That's typically the only voltage that I use is 500 to 1,000 volts. The lower settings, 25, 50, 100 volts, I don't have any regular use for that. But I guess if I was tracing a circuit or something on one of these boards, 25 volts may come in handy. I think that's about all that I use for the 1587. For every once in a while, if there's no batteries in one of the other meters or something like that, I'll use this as a backup for the digital multimeter functions that it has. The Fluke 561 is really the only thermometer that I use that does infrared. This also does have the ability to put a K-type thermocoupler on here, but I rarely use that. 9 times out of 10, I will use just a regular digital multimeter with the K-type thermocouplers that those come with. But every once in a while, the reason why I use this mainly is motor temperature. So the big failure in AC and DC motors is heat. Where that heat comes from, whether it's vibration, bearing failure, insulation breakdown, any one of those can cause the motor to go up in temperature. But the difference, in 10% could mean a lot, and you can't just tell that by putting your hand on it. When we're getting up into 190, 200 degrees, we may be in some motors safe in that temperature for a single phase AC half horsepower motor. When you get up to 220, 230, 240 degrees, those temperatures are hot enough to where you can't keep your hand on there, much less tell the difference between 190 and 220 degrees. So this typically will give me a quick rating at different spots in the motor, what the temperature is, so I can have an idea of how it's running. I do some closed circuit TV work as well too, and I have this FM Systems Camera Master 2. I have a couple more There's one up there over my head. You may not be able to see it. I think it's like right there. I have a Camera Master 1, and I think I've got a couple Camera Master 1s. These are great tools to have if you're diagnosing any analog video signals. This is pretty much my second go-to tool when I'm diagnosing an analog CCTV signal. The reason being is I can tell a lot just from the test monitor I have, and I'll show you that here in a second, to lead me down the path to where the problem may be. However, if I need to accurately measure a sync or certain particular frequency with inside that signal, this device has the filters that hooking your digital multimeter up to and just measuring 1 volt peak to peak is not going to do you any good if you're having issues with it. So anyways, this is generally my second tool. My first tool, if I'm diagnosing any closed circuit TV, is and monitor. Be able to hook up to the signal and actually just look at the quality of the picture separated from the DVR, and then the quality of the picture separated from the DVR and the cable that's actually going to the camera. There could be issues just in that. So if I can get a good quality signal directly from the camera, then we know the camera is doing its job. Then we diagnose the cable, and then we diagnose the DVR, and a combination of both of these will help you do it. I would not recommend getting a video monitor unless it has the ability to generate SMPTE bars, which this does. It gives you a good frame of reference to be able to generate at your head end to come back to this and say, okay, I've got 140 IREs. I know that I've got a good strong signal, and I know I've got a cable that can handle that signal and get me back to my DVR with enough energy to give you a good quality signal. So those are my two CCTV tools that I use, the primary ones that I use. Sometimes I'll hook up a digital multimeter and just check my voltage on it, but I don't get out of the truck to look at a camera without a test monitor. It can just tell you so much. But most test monitors don't have the filters that this does, so you have to have this as a backup. And the other thing that I use to measure in-ground inductance loops is the LCR. Typically, the thing that I'm concerned with when I'm measuring a in-ground inductance loops is capacitance. And for the life of me, I can't think what the capacitance is supposed to be. I'm going to say 200 microfarads to 3,000 microfarads, something like that. That's great magic about TV, is I'll put it right here and tell you what the capacitance of most in-ground inductance loops are supposed to meet within that range. It gives me the ability to measure capacitance of that wire and the inductance of that wire with different frequencies on it, not just putting your multimeter on there, which will have DC and give you just resistance. We need to check to see what the capacitance of it is, because most of these multimeters, or excuse me, most of these loop detectors, that's what they're actually looking for, is a change in that capacitance in the actual in-ground loop itself. So that's what the LCR is for, and it'll give you the ability to test wire runs at different frequencies. It's one thing to put voltage on the end. Let's say you put 24 volts AC down at the end of a wire and test it with your multimeter 2,000 feet away, and okay, you still got 24 volts. Maybe put a load on it and actually see what your current draw is as well too. But it's another thing when you're dealing with high frequencies such as closed circuit TV to actually have something that you can actually change the frequency on and measure the overall impedance of the signal, or the overall impedance of the cable at that point. Just shorten the wires together and putting your multimeter on it and seeing that there's 1 ohm resistance or something along those lines is not going to tell you anything when you're dealing with higher frequencies. So that's why I have an LCR. It's mainly in-ground inductance loops. It has the ability to check individual components. I do carry some resistors on me, and I don't mark the values. I just throw them all in a bucket for telephone circuits. If I need to pull the loop current down or pull the voltage down, I'll typically have some resistors with me. Let's see. So another thing, if I'm measuring current draw off of a circuit I have, is this, I don't even know what it's called. It's X-Tech is the brand, AC line splitter 480172. Sometimes you don't actually have the ability to get in and grab a wire. Well, that's actually what this device will do, is allow you to plug into a regular grounded outlet and clamp on to the circuit now that it's extended this far, and actually measure current from there. Sometimes that's nice too if you just want to put a load on the circuit with a lamp or a drill, and you don't actually have the ability to break those wires either. You can actually put this in your outlet, put your drill on the other end of it, put your clamp meter on it, turn it to amps, AC, and then run your drill and see what the load is, and see if the circuit can actually handle a load or whatever you're trying to test. So that's pretty much the stuff that I carry with me that we're going to try to fill up the Fluke bag with. I carry a Welders Lens. Sometimes if you want to check the back focus of a camera, or possibly, it's kind of hard to do, but check the photo sensor in it to see if it's working. You take a, I think this is a number 5 welder's lens that goes in their hood for when they're welding, and you put it over the actual camera, and it will simulate simulate night. The only problem with that is because of the size of this, sometimes when you put it on a camera, what happens is, oh, you get a Charlie horse in your leg. What happens is because there is, like this particular Northern camera, it has IR in the outside of it for nighttime. Sometimes when you actually will put the lens over it, you actually get reflection from the IR back into it. So depends on how the camera is actually set up. Typically for a box camera where your IR is separate, you can put this over the lens and simulate night, and check your back focus and all that good stuff. And then I carry a couple of just little whips. The CCTV field tester also has the ability to actually supply power from this as well too, which is a nice feature that it has. And then I've got a bunch of 75 ohm BNC to BNC connectors, 75 ohm Terminator, which is very important to have. If you guys are doing CCTV work and you don't have a 75 ohm Terminator on you, I would suggest get one. It's not uncommon that 75 ohm resistor gets blown out in a DVR, and the resistance drops to next to nothing, and you'll get ghosting in your DVR. And you can take this 75 ohm Terminator, take a camera off one of the inputs and put this on the input, and sometimes that 75 ohm resistor is shared across all the channels, and if so, this will put that load on there, and you'll see all your ghosting go away. Doesn't happen all the time, but definitely get one of these. They're not inexpensive for what they are, but $20 could save you an hour trying to diagnose something just in a DVR or something like that. I carry a couple other adapters. Sometimes I deal with consumer grade cameras and converters, so sometimes I need that RCA composite jack, and there's a couple other adapters. I carry all my leads, and that probably doesn't sound all that good next to the microphone. Let me put this back in here so it doesn't get scratched up. I carry all my leads and jumpers and all the various interconnects that I need for these devices in a separate bag. There's so many of them I couldn't actually fit it in here. So get this back in there. So that's what I carry with me these are my what I would say are my backup multimeters, and this is just I believe this is a Pelican case, and can you get that? And that's pretty much what it looks like. Sorry, it'll probably cast a shadow over it, but I'll do a review on how I got this set up sometime in the future if anybody's interested in it. But so that's some of the meters that we're going to put in this bag, and then the next meter that I've got. I think these, and my tool bag, I think these are pretty much the only pieces of test equipment that I really carry. So this is everything. And then I carry a Fluke 990 DSL, which is a POTS tester. So I don't think this doesn't certify. This just qualifies cable. But if you're doing anything with POTS, which I do on a regular basis, this device has the ability to test impedance to ground, voltage to tip ring, voltage to ring to ground, voltage tip to ground, current tip to ground, ring voltage, and so many things just by pressing one button. The value of it saving me a bunch of time having to run all of those tests independently, and then I'm still relying on the accuracy of my 117 and the resolution of my 117 is worth every bit that I paid for it. But it does have some other features, such as the ability to test, if I'm correct, I believe about 10,000 meters of copper. And it also has it can test 2 pairs at one time, and has the ability to measure different gauges of wire at different points in your run. So if you know that you're at 1,000 feet to a particular TR telecommunications room, and you're trying to figure out the other 1,000 feet, and you know you've got 22 gauge going up to that, and then you know you've got 24 gauge going past that. Well, your TDR, the velocity of propagation is a pretty particular. That's why you have the ability to change that, is because there's different gauges of wires with different impedances, and this particular meter has the ability to factor that in and give you an accurate reading up to, like I said, 10,000 meters, which is probably, 5 or 6 times that I've ever used it for, but it does have that ability. The other thing that it has the ability to do is actually save all of that and export it to a bitmap file or something like that, so you can give it to the service technician that comes out and services it. But one thing that I found, and it's not in particular AT&T, I'm sure there's other service providers that do it. Anytime that I tell them that I have this documentation, they don't want to look at it, and rarely do they ever want to meet me out there and confirm that I've got it and confirm that my meter says the same thing that their meter does. And I can't blame them to a certain extent. I mean, you've got an unqualified technician, and then you've got somebody that's has $20,000 in training over here. Who are you going to believe, and who are you going to spend your time on sending a technician out there to diagnose the wire? But anyways, this should fill up that tool bag pretty good. So let's get the tool bag. Let's get the tool bag on the bench and see how many Fluke tools this thing can hold. Let's put it to the test and see what we got. All right, it's time to move the camera, and we'll look at it from there.